Hello, everyone, and welcome. Really glad you have taken the time to join us today. Whether you are connected from my site, an office, or your house, you are happy you are here. So, my name is Marouane Rejeb. I'm the general manager of the Centre Technologique des Résidus Industriels, the Industrial Waste Technology Center, CTRI. And today I will be your guide through an exciting look at who we are and what we do. And I will share the mic with Julia, our innovation and business advisor. Hello, Julie.
Hi, everybody.
So we are testing a new dynamic presentation, and your comments, interactions are welcome. If you have any questions, drop them in the chat. We will collect them for the Q&A portion along the webinar. Here's how our time together is going to flow. As you are seeing in the screen, we'll start with the general presentation of the CTRI. We will answer the common questions: who we are, where we are, what we do, and how we fit into the mining innovation ecosystem, including the freshly mining innovation zone in Rouen-Noranda, the zone d'innovation minière. We will take after that a look at our labs and dig a little deeper into three of them. And then this is the part I'm personally looking forward to. We will hand things over to three of our researchers for a live Q&A. They will be talking about real projects, real challenges, real results, no fluff, no sales pitch, just applied science with industry relevance front and center. All right, let's go. So Julie, can you please start by giving us an overview of the CTRI in few key figures?
Yes, with pleasure. Thank you. So good morning, everyone. Okay, I'd like to walk through a few highlights. It's highlight coming from the 2024-25 annual report. We're just ending the other annual challenge, but go with the other result. Starting with our team. Last year, we were 29 employees, but I'm proud to say that we already reached 35, more than expected, and we're still hiring. The demand from project calls, and it keeps growing, and so do we. What the number don't show is the depth of expertise behind those employees. We have geologists, hydrometallurgists, bio and microbiologists, engineer, and some researchers are teaching to the college at the same time. And people with master, PhD, postdoc, and from all around the world. But truly, what set us apart from the university center is that we're applied research. Our people are hands-on, field-oriented. They don't just theorize, they deliver practical solutions directly to the industry. Next. Okay, rapidly, on the activity side, the number you see represent a constant flow. Okay, when we are talking about project, at any point we are managing around 50 projects at the same time, simultaneously, at various stage, naturally. Like some are at the launching, some closing, some midstream. So, and the time range is sometimes a few weeks, but it can take a lot of months too. And the source are you see the source, we have a lot of type of industry, a wide range, can be mining, metallurgy, and so on. I'll let Marouane, Mr. Reject, to go through that. Students are not just observators, they are integrated into live project as intern, getting real field experience. And finally, knowledge transfer is a core value for the CTRI. Those 12, when we are talking about presentation, go well beyond what we are looking today. Our researcher present conference, congress, sharing finding openly, always within the boundary of confidentiality agreement. when required. So that's it. These numbers tell a story, growing, active, and deeply committed organization, but behind every figure, there's a vision. And no one is better placed to speak about it than our general manager, Mr. Rigid, to tell you more about who we are and where we're headed. So I let you go through, Marwan.
Thank you, Julie, for this overview. So here was some numbers concerning our research center. To come back to our history, the CTRI was founded in 2001 within the Cégep of Abitibi-Témiscamingue, right in the heart of one of Canada's most active mining regions. That's not a coincidence. Being embedded in Abitibi-Témiscamingue means we are not like doing research just in a vacuum, but we are doing it next door to the industry we are serving. Over the years, we have grown significantly. A major milestone came in 2015 with the launch of our pilot plant, and the most recent addition to our center was the greenhouse facility coming online this year. We are also part of strong network, a member of the Réseau des CCTT, Quebec's College Technology Transfer Centers, and we are directly connected to the Zone d'Innovation Minière, mining innovation zone, a provincial initiative designed to accelerate the mining sector's transition toward more sustainable and competitive practices, as you see in the screen. In other words, we are plugged into the right network, in the right place, and in the right time. In the next slide, you will see how our mission and how we work. So if we read it, it's to explore, identify, and propose innovative solutions that aim to increase the value of underused and natural resources and industrial waste by accelerating the implementation of eco-responsible and profitable business practices. Eco-responsible and profitable. Like the two words in the same sentence, it was intentional to use it this way. Why? Because at the CTRI, we are not just thinking about the environmental compliance. We are thinking about how sustainability can actually make your operation more competitive. A short presentation I like to give, like I always like to give about CTRI, is that our goal is to create a business opportunity behind every residue. So how? By valorizing residues and their used resources, or by also reducing the waste at the source, or by adopting new processes. Our scope are the mining sector, the forestry sector, agri-food, and municipal sectors. But for most of us in this room, we are most interested by the mining aspects we are working on. So here in this slide, you are seeing our 5 laboratories. The first one is dealing with the biomass and the bioenergy, biotechnology, and bioremediation. Third one is decontaminated effluents and processed waters. The element 08 concentrating on the critical and strategic minerals, and finally, the ore and industrial mineral treatment. 5 labs, 5 areas of applied expertise. Let's look now for 3 of them. The 3 first one I have spoke about. So you will see here our ore and treatment mineral processing department, which is focusing on the extraction and recovering of conventional minerals like gold, silver, for example, and also critical and strategic minerals such as lithium, cobalt, copper, niobium, graphite, etc. From both primary sources, think like here for fresh ore, and secondary sources, we can think here about tailings and industrial residues. Our equipment list reads like a serious industrial operation. 2 pilot plants able to process the smallest up to 50 kilograms per hour, and the bigger one, the second one, up to 1 ton per hour, along with crushing, grinding, gravimetric, and magnetic classification. On the expertise side, we work across geometallurgy, hydromet, and waste management. In the next slide, you will see our second laboratory we're speaking about is the water treatment and effluents one. We, as you know, mining produces a lot of water. A lot of it and managing that water, like whether it's on its processed water, the drainage, or the mine effluent, is one of the most pressing regulatory and operational challenges the industry faces. So our process water and effluent department tackles this head-on. Our work covers contaminants like metals, metalloids, and nitrogen compounds, for example. We also do in this lab the environmental characterization and toxicity assessment, and we are actively developing technologies aimed at reducing the greenhouse gas emission. In the next slide, we'll talk about our biotech and bioremediation lab. And this may sound like more like a research lab than a mine site, but the applications are very real here also. Our biotechnology and bioremediation team focuses on restoring disturbed sites using plants and microbes to heal impacted landscape. We also support pre-mining planning, substrate preparation, and revegetation design. For both major or junior mining companies, this directly connects to end-of-mine obligations and ESG commitments, where science meets real-world requirements. All right, so that brings us to the end of the formal presentation. So I hope you have got a clear picture of the general aspects about CTRI, what we are capable of, and why having this kind of applied research capacity is valuable for our industry. But before moving for the part you have been like waiting for, let me define just how you can collaborate with us. If you are a mining service provider looking to run a proof of concept, we have got you covered. We connect you with the right mining partner, run the tests in our labs, and act as a neutral third part to tell you clearly if your technology works. And if it doesn't, there's no problem. Our experts help you make it work through process optimization. If you are a mining operator, whether in the concentrator, in the site, or in the control room, and you are dealing with residues, looking to improve process, adopt green solutions, or modernize your operations, we are here to help through tailored services offer or applied R&D project. We turn your challenges into real opportunities. So here I'm giving the mic to Julie to introduce three of our researchers who are going to talk to you about real projects they have been involved in. We will be going into like a Q&A mode, so please fire your questions into the chat. We have already got a few collected, and we will work through as many as we can. Julie, I will leave the floor for you. Open your mic.
Thank you. During the time that Marwan will go and see the coordinator, the first one is Ali. I introduce Ali. He's a researcher and coordinator at CTRI since 2022, specializing in industrial water treatment. So highlight his unique path, chemical engineering in Iran, then water science, PhD in Quebec, theory meets practice. His niche, turning complex environmental problem into concrete industry-ready solution, and keys area, it's electrochemical and hybrid treatment, wastewater, bench to pilot R&D, biomass valorization. His background, next slide. You see, I don't want to go through that. He has a lot of background, 3 postdoctoral fellowship. And but I want to put emphasis on what drives him, seeing direct impact on industry and environment. CTRI speed from idea to application when is what energizes him daily. And he has a lot of energy, honestly. I'm surprised sometimes. I don't know how he is doing that, but he is managing a lot of projects, a beautiful team with him. His pride, lab scale concept, scale to real industrial pilot system. If we are going through his contribution and outreach, we'll see that he have more than 25 article, book, chapter, conference, and he has also a patent field. Is really, if you are looking on the other side, from a lot of organization, is guest editor or is co-investigator or going through helping in the committee and so on. If you're asking Halley, what is his goal? He's telling you, he will tell you for sure, turning complex environment challenge into concrete industry-ready solution. So I let Ali and Mr. Riget continue and go further in their laboratory.
Thank you, Julie. Hello, Ali.
Hello, Marwan. Thank you, Julie, for nice introduction. And Marwan, welcome to our contaminated effluent and process water lab.
Thank you, Ali. So we are fortunate to have you in our team, really.
Thank
So
you.
can you tell our audience how we can help the mining industry in your department, please?
Yes, as you know, there are some environmental challenges for the mining industry. For example, contaminated water or even air or waste. And there are also some regulation and regulation pressure from government standards. So we need to look forward to the sustainable solution for this kind of contaminant. So at CTRI, we can do several things for mining industry and also for the companies that are developing the process for mining industry. We can act as intermediate as well. So in our department, we are working on process water treatment in mining industry in order to remove some contaminant and meet the regulation standard. And also to recycle water or reuse it in the plant. Also, recently we we were starting to do some project related to gas emission and atmospheric emission contamination from mining industry. And also we are working on a specific contaminant or emerging contaminant in mining industry. So with our team, we can find a solution and start doing the lab test, and after that piloting and the scale up for the solution. We can also give a service for monitoring and environmental monitoring to follow up the specific content.
Thanks. So can you give us some examples of the contaminants you are working on?
Yes, currently and also in the past, we are working on contaminated solution at lab scale, pilot scale, or even in the field. For example, for contaminated of metals like molybdenum, copper, nickel, arsenic, manganese, and also selenium. Or even anions in mining water like sulfate, nitrate, and also phosphate, or even ammoniacal nitrogen or cyanide that we are handling them in gold mining. So we we offer different of treatment processes like biological with collaboration of the other department at CTRI. Chemical processes or even electrochemical processes, physical procedure, adsorption, even ion exchange, and also advanced oxidation processes in passive way or active way. It depends on the solution and required of the mining industry. We can also modify the material to be used as adsorbent and for clarifying the water. And also, on the other hand, we can handle the sludge and valorization the sludge sometimes. because you know that after treatment of water, we produce sludge and we need to densify it or valorize it in different ways.
Great. And what are the other aspects you're working on?
In addition to the removal of contaminants, we can also do geoenvironmental study to predict if the tailing or solid waste can generate contaminants during the time. We can do the test at different pH according to the standard of Quebec and also ASTM standard. We are working on acid mine drainage and also neutral mine drainage to increase the pH and also at the same time precipitate the metals like iron, aluminum, and manganese. And with our subcontractor, we can do the water toxicity test and also data verification as a third party for the companies and for mining industry.
And can you told us about some projects you were being involved on? You have
yes, the example of the projects that I introduced you present you two projects that we got the fund from FRQ, Fond de Recherche de Québec, and also from NSERC, the federal fund. For example, removal of ammoniacal nitrogen in underground mine water by collaboration of the industry in our region, and also for removal of sulfate and nitrate in mining industry using anion exchange resin.
Great. And can you tell us about some of the upcoming developments or the equipment we have here next to us?
Yes, we have lots of equipment at pilot scale and also at lab scale. For example, according to the needs, we can assemble the system like high density sludge neutralization, active treatment. We have also advanced oxidation system process like ozonation and the UV system. We have filtration system. We can use different type of membrane and also computer controlled system for absorption in water and also in gas contamination, and also electrochemical system like electro-oxidation, electrocoagulation, and even electrodialysis system.
Thank you, Ali.
Thank you, Marwan.
For
You're
that
welcome.
information. So, Julie, the floor is yours.
You are mute, Julie.
It's always my problem again. Pierre, can we tell us if we have some questions from this laboratory?
For now on the chat, there are no questions, but if you want to write one, you can, or you can just open your mic, and if anyone wants to ask anything to Ali, he's available for a few minutes. It's like you want. If not, we will continue with the next presenter.
And we can go through a question at the end of the global presentation also. So the next laboratory is with Selma Hetahid. Selma is the coordinator of the Biotech and Applied Ecology laboratory, and she's with us since 2021. Yes, it's going very, very fast, Selma, huh? She's trained as an agronomic engineer, and she have look where she have worked in Tunisia, Greece, again all around the world. Her specialization is environmental biotechnology, bioremediation, biohydrometallurgy, which is really something popular actually, and residual mineral management. Core focus: bring research in the real world and impact for businesses and communities in the region. Next, we'll go through rapidly her background. You see again that she has a lot of background that she bring with us. A postdoc finally in ENRS, and she's now coordinator since 2024 at CTRI. Her pride is securing funding to modernize the CTRI microbiology laboratory. And it's really a nice laboratory. And by the way, everybody who is listening, when you are coming to one another, you can come and visit us all the time. The next one is our contribution. Again, she is doing a lot of stuff, a lot of engagement, outreach. And if you are asking, again, Selma, what drives her? And she will absolutely answer that seeing her research transform into real solution for business and community in the region. That's really what is the drive of Selma is really there. So I let you continue, Marwan and Selma.
Thank you, Julie. Welcome, Salma. Hello.
Hello, thank you, Julie, for this nice introduction. I want also to thank everyone who is attending the webinar with us. So let's go.
Thank you. So, Salma, can you share with us some work you have done, like related to the bioremediation?
Yes, of course. In our laboratory of biotechnology and applied ecology, we have conducted many projects in related with mining biorestoration. The first project was a project dealing with selenium bioremediation. In the frame of this project, we developed an analytical method for the analysis of total selenium and its speciation as well. After this, we tested a bioremediation technology, which is based on constructed wetland. And for this technology, we have combined the use of some native plants, which are tolerant to Nordic climate, with the use of biomaterial, which is biochar, to test its ability and its capacity for the sequestration of selenium and other metals. So this method have demonstrated very good results, and the selected plants demonstrated also a good potential of bioaccumulation of phytoextraction and bioaccumulation of selenium and other metal. Then the second project, we have another project about bioremediation. It was dealing with the development of innovative method for bioremediation of mining sites. For this project, we have developed a growth substrate in the form of panels for the revegetation of highly disturbed sites. For these panels, they consist of a mixture of residue of agriculture and forest residue and peat, which can improve and promote the growth of plants and also enhance the success of the revegetation of the mine site. Then we had another project. It was about, in this project, we wanted to combine two concepts, the concept of mine site bioremediation with the concept of circular economy. So for this project, we developed a new substrate containing a fertilizer, which was derived from mining effluent for the production of forest seedling. So this fertilizers was valorized from the mine effluent containing ammonium sulfate. So we take this residue and we formulated a granules of biochar that was used for the production of forest seedling and mainly the production of spruce species in this case. Then we had also another project about circular economy and biorestoration. It was development of an eco-intervention model to valorize municipal sludge into a mature compost. For this project, we started by developing techniques for deshydratation of the sludge. Then the stabilization using testing many recipes with different structurant agent. And after this, once we produced our compost, we started by testing it into semi-pilot scale at plots for the production of forest plants. Then we moved to we upscaled this and we moved to a bigger scale, and we produced like 7 tons of compost, which are ready to be used for a mine partner for the biorestoration of their sites.
So here it's all about the bioremediation restoration.
Yes.
And what about the metal-like extraction? We are seeing like in this slide, the biohydromet expertise.
Yes, in fact, in our laboratory, we are able also to apply biological approach for extraction of metal using biohydrometallurgy, which is a technique that is based on the use of microorganisms to solubilize the metals while feeding on the mineral matrix. So we applied biohydrometallurgy for many case studies. We applied this for the biooxidation of gold, which is encapsulated in a silver mineral. So these microorganisms were able to help us release the gold, which is encapsulated in these matrices. Then we applied also the biohydrometallurgy for the bioleaching of copper from industrial slags. We applied this in different conditions, aerobic and anaerobic. And we recently also we have achieved a project about nickel bioleaching from low-grade ore. So for this technology, we are able to apply it thanks to our laboratory of microbiology of biosafety level number 2, thanks to a permit that was delivered by the Public Agency of Health of Canada.
Great. And finally, Salma, how do you apply like biological approaches on the treatment of effluents?
Okay. Yes, actually, we apply also the biological approach for mine effluent treatment. For example, we applied this for the bioremediation. We worked on a project of bioremediation of mine effluent in order to help remove the nitrogen compound.
You can see the next slide.
Yes. Okay. We used a microbial consortium for the bioremediation of nitrogen compound. So we followed like the reaction of nitrification and denitrification. And for this project, in order to enhance the performance of this microbial consortium, we combined this with a very efficient biological treatment process, which is called moving bed biofilm reactor, which is a process based on the use of carrier or plastic media in order to help growth the biofilm and multiply the bacteria or the archaea, or in order to enhance the removal rate of nitrogen compound. So in this project, we optimized this process at different scale, at batch scale, semi-pilot scale, in order to optimize the different physicochemical parameters that control this reaction of nitrification and denitrification. Also, I will give another example of biological treatment. It was using the floating island, or we can call this constructed wetland also. For this, we choose certain plants which are native to Quebec and which tolerate really very extreme Nordic condition. They have immersed their roots in the basin as shown in this photo, and through these roots they were able to capture the metals contained in the mine effluent and to extract these metals and then to accumulate this in different parts of the plants, in aerial parts and underground parts. It was this demonstrated also its efficiency. So, yeah, at the end, I just want to mention that we will continue working on this project thanks to a new platform of bioremediation that we have put in place here in CTRI. It is a greenhouse of 300 square meters, thanks to a funding of the Canada Foundation of Innovation, Quebec Ministry of Economy and Innovation, and the Economic Development of Canada.
Thank you, Salma. It was really insightful. Julie, open your mic this time and present our third researcher, please.
Yes. You're going to the laboratory with Stéphanie Somo. Madame Stéphanie Somo. She's coming from France, so I can take my French accent. So she's there with us for 20, no, not with us. She's on the industry. She's on the research part for 25 years now. A green hair like me, huh? So in the mining industry, recognized expert in critical and strategic mineral. She's with us since 2021, and she worked at McGill University with COREM in Quebec. Her area is really sustainable extraction, green hydrometallurgy, mineralogy, environmental geochemistry, and process water treatment. So with 25 years, she has a big head, a lot of area. And that's one point that I want to insist. All those laboratories are working together, so that then you recognize the expertise which are really helping each department. Her background, again, she has a PhD geoscience, and she loves field work. We need to grab her to keep her seat here at the office. Plan visit as much as data analysis, a rare combination of scientific rigor and field practical. Two world-class achievements. First ever demonstration of sustainable magnesium metal production and a green process for decontaminating processed water while recovering valuable metals. Contribution, again, I only put a few. Much of our work is under confidentiality agreement, a testament to the trust of the mining industry for us, for her. Active in ICM, CEMI, the International Mine Water Associations also, and really volunteer. I don't know where she's taking, where she find all that time again. Then what drives Tiffany for more than 25 years is in the mineral industry, a conviction, sorry, it's again my English, it's my 4th or 5th language, if we can say that it's a language that I can go through, but a conviction born the day I saw dead fish in a river in France. Madame Somo et Monsieur Recep, Mr. Recep, Madame Somo, go ahead with your laboratory.
Thank you, Julie.
Thank you, Julie. Good morning, Marwan. Hi, everybody. So I'm very glad to be here with you this morning. As my colleagues presented you before, a lot is done at CTRI about sustainability in the mining industry, because at BTB we are at the heart of the mining industry. So what sustainability means for us? Environmental friendly, like stabilizing waste, effluents, gases, but also energy efficient processes, carbon neutral processes, maximizing waste, effluents, emissions, all we can do with the waste matter, how we can valorize these things, and maximizing the extraction of natural resources, mineral ones specifically. I will speak in our department today. So could be minerals, but water as well. So as a quick example, I just show here, no, just before in back one, thank you. So you can see a pegmatite at the bottom of the slide, which is a rock containing very nice minerals like the spodumene, which is containing lithium to make batteries, but it also contains feldspars, quartz that could be useful at other for other purposes in the industry, like glasses or ceramics. So when we speak about sustainability, this means and maximizing natural resources, this also could be co-valorization of minerals. So instead of just taking a little part of an apple when you eat an apple, just make the most of the whole apple. Thank you. So now we can go to next slide. So the mining industry is keen in innovations, and that's our pleasure to be here to help. So the mining industry is undergoing also fast changes at the moment to meet society's needs, like the energy transition, digital transition, national security. So at the department, we are gonna show what we can do on the next slide. So basically what we can do is testing some processes, optimizing them, de-risking some processes that maybe you have in mind and you would like to get some room, laboratory space to test them and to check how it works on real waters, on real waste that are in the region. We also combine that to training, as Julie mentioned before, and Marwan also, for students, but also sometimes our plants are used by companies to train their people before they go on site in another country, for example. And we are able to upscale some processes, mineral processing, in pyrometallurgy, in hydrometallurgy, and also for the characterization, we have some facilities for mineral and geochemical characterization and gas emission characterization. I will come back to that a bit later.
Oui, so I will take you like one step back. Can you tell us where we are now in this?
Yeah, I didn't mention, sorry. So today we are together with Marwan in the mini pilot plant. So he mentioned we had two kind of plants for mineral processing. This is one of these that you see here. That's the small one for 50 kilos per hour treatment. And it is equipped with all equipment for continuous mineral processing, from crushing, grinding, milling, conditioning the pulp, doing flotation, and even a small system to make or to train students on cyanidation. So that's all you can see there. You can see also a very nice flotation columns that we use. We can use both for ores or for water treatment.
Can you go like deeper in some of the projects you was like involved in?
Yeah. So on this plant with our colleagues from the CEGEP, we did run a project, for example, for the flotation of rare earth elements. There are also some tests that have been done with cyclones or with filtration to test new products from our partners. So if we go deeper in mineral processing in the lab or in the two plants, we can go through comminution, gravity separation, magnetic separation, classification, flotation, filtration, all the common things. We also have some uncommon equipment for grinding, as you see on the picture at the bottom of the slide, which is self-frag or high voltage electric pulse fragmentation equipment. All these equipments may apply to tailings, inorganic waste, ores, processed waters, as I said, with the aim of sustainable recovery of values from all these matters, decontamination, sometimes of soils or industrial waste, and valorization of recovered metals and minerals after that to maximize the natural resources. And also with the aim of minimizing waste, tailings volumes, water treatment sludge.
Oui.
So if we go to the metallurgy setups, we can see that We are equipped for gold cyanidation. You can see the rolls with the bottles that are generally used for that. As we mentioned, we are on the Larder Lake Cadillac fault zone, so that's important for us to be able to study all kinds of gold ores, whether they are easy, complex, or refractory, or even double refractory gold. We also work, so some of my colleagues are also working on alternative reagents to cyanides. As you've seen with CEMI, we can use bioleaching or biooxidation of sulfides to prepare our matter before cyanidation. And we also worked on some projects using specialized resins and sorbents to recover gold once leached. Other kinds of projects that we run at CTRI in the recent years are, for example, treatment of asbestos waste, from which we separate the minerals using our mineral processing equipment and then leach the minerals. Like in a reactor, you can see at the top of the picture here, the green reactor. That's leaching the ore to recover the metals into the liquid form, and then we purify that liquid and we selectively recover the metals of value for the industry. We did also work on lithium, floating spodumene concentrate, and then roast calcinating it, and then leaching it with specific reagents, and going to the production of lithium carbonate, which was quite pure, with our pressure power reactor that you can see also at the bottom of the slide, on the left bottom of the slide. And as Julie mentioned, we're also working on metals like magnesium, and Marwan mentioned that we're working on greenhouse gas analysis, and also Ali. So this kind of equipment that you see at the right of the bottom slide is the equipment, specific equipment to detect, measure how much CO2, for example, is released from the rock that we are studying. So very nice equipment. Thank you.
Thank you. Can you go deeper about the self-right
yeah, we can go on with high-tech equipment that we have at CTRI. It's the high voltage electric pulse fragmentation equipment. Compared to traditional technology, it has a high efficiency of fragmentation, especially for hard rocks. However, what we discovered with the partner is that the heterogeneity of the rock is important. We try to fragment a very homogeneous, very hard matter, and it was so-so. But for natural rocks, like you can see on the pictures here, we have still a pegmatite. It's from literature. It's not our work, but we did the same, but we didn't have so nice pictures, so I took these ones. So at the beginning, you have a rock, a pegmatite, then you use the self-frag. The principle is like if you were lightening the rock, and then the minerals are separated at the edge of the minerals. So that's what makes the achievement of an excellent mineral liberation. Like you see at the left bottom here in the picture, you can see spodumene, which is very well liberated. So it's very easy to use it for leaching after that, because there's no more impurities included with it. However, the limitation of this equipment is that, well, an advantage for mineral processing is that it does not generate many fine particles. But on the other side, when you want to grind very fine, it's not the good tool. Another thing is that it works underwater. So if, for example, you want to recycle batteries with lithium metal in it, forget it, don't use that, it's too dangerous. And the other limitation is that for the moment it has low capacity. It's around 10 tons per hour that you can treat with that equipment. So it can be useful for the mineral industry, but that should be a very specific stream that you go with that equipment to take benefit of it.
Thank you, Stephanie. It was very interesting. And this is like a small picture of what we are doing in the CTRI. There is also all the hydromet we're working on developing by now. Thank you for this quick picture. And I will leave the scene for Pierre and Julie while I'm coming back to my office.
Thank you, Marwan.
Bye-bye.
Yes, thank you. But I want to take a moment to thanks. Okay, sorry, it's something that we want really to do, to thanks Ethos, which are the one who make contact with CEMI, Mika group. Francesca is over there. Francesca, you are really an important player in our ecosystem here. I'll let you, during the time that Marwan is going back to this office, I want to let you the time to talk about your organization.
Thank you, Julie, and congrats for the great presentation. So quickly about Ethos, we are a boutique firm specialized in responsible business strategy, ESG, and sustainability. If you don't know what ESG is environment, social, and governance. So it's a framework around sustainability. We work with all type of organizations of the mining industry. Yes, innovation organizations like CTRI and also like CEMI, but also and principally with the mining operator, mining exploration companies, and also mining suppliers. We can go to the next one, please. We are solidly based in the Quebec mining ecosystem. We act as a strong link for responsible and sustainable project development. So in the case of today with CEMI as a main partner, we act as the link of Quebec ecosystem with other innovation hubs and organizations across Canada through the MICA program. In today's case, we were happy to act as a link between CETRI and all of the you participants of today's webinar to present you CETRI with one of the finest expertise in the Quebec ecosystem. So we work with CEMI, but with other organizations. So if you're interested in knowing more about the Quebec mining innovation ecosystem and also about how it can link to Quebec and with other provinces, we are happy to act as the link always under the MICA program and with the CEMI. So thank you so much for this little moment, Julie.
Thank you. And like I said, it was really appreciate all what you have done with us, with Mika, CEMI. It's perfect. Then I have one question, and that comes because there's some people from CTRI here, and it's for Selma. Sorry, Selma, they are asking me when the greenhouse. Talk just a little bit about the greenhouse, the new greenhouse we have here. They are so proud having that.
Yes, Julie, for the greenhouse, you are asking about the date. That was the question.
Yeah, what is exactly the square feet? I don't remember how big is it.
The square, it's 300 square meter.
Oh
almost
my goodness.
Yeah, it's very big, and we have like 2 pots in this greenhouse for contaminated soil and even to do other activities, for example, in collaboration with the community or others. So it's very big, and we will be able to do many applications about applied ecology, and also to combine this with many biological approaches that we already do in the laboratory of microbiology.
It's another reason to come and visit us. And honestly, it's really nice. So that's all for me. Thank you, everybody. I let Marwan continue the presentation.
Yeah, thank you everyone for your time. We'll show some of the financial contributors, the funds we use for our R&D projects here in the slide. The next one is about some of the partners we are collaborating with. This brings us to the end of today's webinar. And for any further information, please feel free to contact us. Our details will be shared in the chat. And if you are ever in the area, we'd be happy to welcome you for a visit of our facilities. Thanks, everyone.